All right, for this question, they're giving us the series, Maclaurin series for ln of 1 plus x, so that's given. So if they give you a series and they ask you to build another, it's often going to be like substitution, multiplication, something like that. So what I noticed is I'm just going to replace where the x is, I'm going to replace with x over 3. So I'm going to leave myself some space because I know that I'm going to times by x. So the first term, the x becomes x over 3. The next term, I'm going to have x over 3, squared divided by 2. Then I'm going to have an x over 3, quantity cubed, divided by 3. I'm leaving myself a little bit of space because I know I'm going to be multiplying by x. Then I have x over 3 to the 4th over 4. Pay attention to how many terms they want. They want the first 4 non-zero terms and a general term. When I do the general term, I'm doing the same thing that I did on the others. I'm just replacing. So in place of the x, I'm just going to write x over 3 to the n over n. All right, then I still have to multiply by the x. So now I'm just going to, next to each term, put a times by x. X, x, x. Same thing here, I'll just put an x. So that would be all of my points for part A. They have it simplified on the key, so I would box this, and then I have a feeling I'm going to need it simplified for the other parts, so I'm going to go ahead and simplify. So on A, I'm going to simplify this. So f of x is equal to the first term, x times x, that's going to be x squared over 3. The next term, I have x times x squared over 3 squared, and divided by 2, so there's just really the 2 there as well. So then the next term I have x times x cubed over 3 cubed, and the 3 on the bottom, I'll just go ahead and put there. Looks a little like 33, I want it to be 3 cubed. Okay, so then I go to the next term, which is a minus. It's x times x to the 4th over 3 to the 4th. We were dividing by 4, so that's still just in the bottom with it. And the general term I'm really going to have to worry about, so negative 1 to the n plus 1. Let's see, so this is x to the n over 3 to the n times x, and that x is being divided by n. So again, I'm simplifying this. I'm not boxing it. I want them to grade this answer, but the simplified answer I'm going to need for the rest of the question. So I have x squared over 3 minus x to the 4th. I'll leave this as 2 times 3 squared. This is a plus. There's a, this one's cubed, x to the 3rd. This one is x to the 4th. And then 3 times 3 cubed. I'm not going to simplify. It makes the pattern a little easier. This is x to the 5th. Then I have 4 times 3 to the 4th plus dot, dot, dot. The alternating piece hasn't changed. When I do this term, I've really got x to the n plus 1 over, I'll put it in the same order as the others, n times 3 to the n. Okay, so this general term, simplifying the general term on this particular question was really important for doing the rest of the problem. The one on your test tomorrow, you will not have to come up with the general term on your own. That's what makes this question so difficult. The general term will be given to you. But we're going to need this general term for the next part of the question. Okay, so on part B, now again, I've simplified it, but I want to star this answer, or box this answer. That's the one I want graded. Okay, B asks for the interval of convergence. Anytime you're asked interval of convergence, you're going to do ratio test, unless you recognize that it's geometric. This one isn't quite geometric. So ratio test, you always do the n plus 1 term divided by the nth term, or multiplied by the reciprocal. So the n plus 1 term, since it's absolute value, I'm going to go ahead and drop this alternating piece. So I have x to the n plus 2, because I'm replacing n with n plus 1. The bottom I have n plus 1 times 3 to the n plus 1. I'm timesing by the reciprocal of the nth term. On the rubric, you'll see that you're going to be awarded a point for this setup. So you get points for doing this setup. So when you reduce, make sure it's clear that I can still follow that you had the setup. X to the n plus 2 and x to the n plus 1, that's going to reduce. This is like x to the n and x squared. This is x to the n and x to the first. So the x to the n's cancel. X reduces so that we just have an x on top. So I have an x on top. This 3 to the n and 3 to the first, the 3 to the n cancels out. So I have left an n on top. And on the bottom, I still have the n plus 1, and I have a 3. So now I need to make sure to write the limit notation in front. It's the limit as n goes to infinity. Still have these absolute value bars. As n goes to infinity, this piece here, the n and the n, those are going to cancel out and basically go to 1. So we end up with just x over 3. So it's the leading terms. So I wouldn't really show anything. I'm just going to say that that limit goes to x over 3. Still in absolute value bars, so that's less than 1. So you find the limit, you're going to get points for setting up the ratio, a point for computing the limit, and then to set up your interval. So we're going to sandwich x over 3 in between -1 and +1. I could times by 3, so I'm sandwiching x in between -3 and +3. Okay, now we need to check the endpoints. So we've got our interval. When we check the endpoints, we are checking the endpoints into our general term. So I'm going to say, okay, I'm going to check what happens when x equals -3. So all I'm going to do is take -3, and I'm plugging it in for x in my general term. So this would give me the series -1 to the n plus 1 and -3 to the n plus 1 divided by n times 3 to the n. So as I simplify, I want to simplify before I use a test. Both of these are being raised to the same power, so that means I can multiply the -1 and the -3. So if I multiply those together, this series would give me a +3 to the n plus 1. It's being divided by n times 3 to the n, which I can reduce because really that numerator is 3 to the n times 3 to the first. So the 3 to the n can cancel. So this series is equivalent to 3 over n. The 3 doesn't really change it. It's still a harmonic series. So I can call this harmonic, and a harmonic diverges. That would be all the justification you would need. So because it diverges, I will not put an equal to bar there. I leave it as a strictly less than. Then I have to check the other endpoint. So now I'm going to check what happens at x equals +3. So again, I'm doing the same thing. I'm just replacing the x. So now I'm coming to here, and in the x, I plug in +3. I still have the alternating piece, so I still have the -1 to the n plus 1. In place of x, I'm going to write 3, so I have 3 to the n plus 1. And on the bottom, I have the n times 3 to the n. Okay, just like the last one, both of these are being raised to the same power. Well, in fact, I won't multiply them this time. I like to keep that alternating piece separate. So instead, what I'm going to do is I'm just going to rewrite this piece as 3 to the n times 3 to the first. So the 3 to the n cancels out. So this series is still alternating, unlike the last one. I have a 3 on top, and I have an n on the bottom. So it's almost identical to this one. It's just that it is alternating. That means I can call this one an alternating harmonic, and an alternating harmonic converges, I'm sorry. Alternating harmonic converges. Because it converges, I'm allowed to put an equal to bar right there. That is my interval of convergence. Okay, all right, then on to part C. Part C is the error question. I'm just gonna give myself a little bit more space. So on the error question, it says a polynomial that subscript 4 is 4th degree, and that's what they're also stating to make it obvious. So we want a 4th degree Taylor polynomial centered about 0, and they want us to find the upper bound. That just means what is this error less than? So on part C, when I do part C, I'm going to say the polynomial of degree 4 at 2 minus f at 2, that just represents the error, is less than or equal to the absolute value of the first unused term. So because it is an alternating, I can do the first unused term. go ahead and say first unused term. So degree 4, this is where it's helpful that I had this polynomial written here. So a degree 4 would be this approximation. So to there, that would be my approximation because I want to go to degree 4. So my first unused term is this term right here. So that would be my first unused term. So this error, I'll keep this written as the polynomial of degree 4 minus the actual value evaluated at 2 has to be less than or equal to that term, the x to the 5th over 4 times 3 to the 4th. You just can't leave it with an x in there, so we have to replace x with the 2 because this error is evaluated at 2. So instead of writing x, I'm just going to write a 2. I will not simplify this at all. The instructions just said find it. They didn't say to compare it to anything. They didn't say show it's less than anything. So that is my answer. That is the largest the error can be. So that is this free response.